to just check if we are connected to a stream. Perfect. Okay, perfect. Let's go. Yeah, yeah. What we'll be doing today is like we'll be adapting to a new format of solving because obviously it's a very time consuming and I think I need to increase my efficiency. I need to increase my efficiency like solving more questions in same time interval now. Need to increase my efficiency. Okay, so what we earlier used to do was like four array questions per day, right? And four linked list questions what we had decided. But now what we'll be doing is okay. So okay. Now what we'll be doing is like in 1 hour. What we'll be doing is in 1 hour we will try to solve two easy, right? Of each topic. Like first is array, two easy questions of let's say linked lists, LL, right? And yeah, this is like most and and two easy questions of let's say a more complex topic, trees. Then yeah, this is what like we should be planning, and I think this is the more appropriate planning. I think in 1 hour I'm like completing more topics, right? And then in the next session we'll like in 2 hour we'll try to solve two medium and again two medium questions of both array and here is linked list, right? I will be giving 10 minutes to each question in this, 10 minutes per question, and here I think so it should be like 2 4 6 perfect, 6 questions, 60 minutes, perfect, 1 hour. And here I will be doing like I have four questions, 4 divided by 60 is like 15 minutes. Yeah, no, not 2 hours, it's 2 hours, so 120, 30 minutes. Yeah, perfect, 30 minutes to each question. If not, move ahead. If you can't solve it, move ahead. uh, okay, now next would be I think this is what will be following till 10th of Jan, till 10th of Jan. So with this I will be like yeah, 10th of Jan, and after that I will be like try to solve medium questions. Yeah, I think it should be like medium questions of trees 2 hour, and then medium questions of linked lists or more anything. Instead of we'll push pop out array from this and then put another stack, yeah, perfect. So this is what we should I am planning to do. So let's move ahead. Let's see. Well, doesn't matter. Okay, yeah. So let's go ahead. Difficulty easy. Tags again. Array one. Am 50 plus days. Oh, we'll be sharing it. I don't know. maximum product difference. I think I solved this. Yeah, I solved it. Java. Let's start. The product difference between two variables. Okay, maximum product difference. That was maximum product of two numbers as defined as AB and CD. Difference between A into B, C into D. For example, product difference between 5, 6 and 2, 7 is 16. Okay. Given integer nums, choose 4 distinct regions such that the product difference between them, between pairs, and is maximized. Okay. Well, whenever there's an array, first think of like sorting. Then comes like hashing. Like these two are basic things. Now, what if we apply sorting, right? Yes, like we need to like maximize the product difference, right? AB into CD. Now, what we need to do is like I need to find AB as max, which is like max of A into B minus min of max of which is like well, I think it should be something like it mean I need to maximize my A into B and minimize my C into D, right? Which is maximize A into B and minimize C into D. Now maximum and whenever we have maximize and minimize sorting by default comes into our mind, right? So even if we apply sorting, so what would be like we in this example, like if we like sort the elements 5, 6, 2, 7, 4, right? Now after sorting 2, 4, we'll pick 2 and 4, and 6 and 7 will be maximizing 6 and 7. 6 7 6 are 6 into 7 minus 2 into 4. Perfect. After we do. Now like if we sort, sorting will take off n log n time minimum, which is like average case you guys are using merge sort. Now of n log n time will be taken, and then it's like of 1 to just calculate this. It would be like some maximum, just picking out these numbers from the sorted list. It would take off n log n time. But like can I decrease it using like let's say if we use q, parity q, putting it putting all the elements into parity queue, then picking only first two, and then last two elements. First two would be maximum, last two would be minimum, right? It would again take me time would take off n, right? And space would be off n. Now that's time has been decreased to of n. Now can I like do more? Like, can I decrease space now? Like like am I audible first? Perfect. Like let's say um, I can find uh, first maximum and second maximum, like largest and second largest, using a two pointer approach. I can find. Now what if I can find similarly for smallest and second smallest? Yeah, I can do that. Yes, I can do that. Okay, now that's I think a better solution. It would take, if I could do that, my time would be off n and my space would be off 1. That's much better. Let's see, let's move ahead. Like let's say what first we'll find the biggest element, right? Now what will be like my I, let's say my current element, current would be less than, let's say, nums length, and my bigger my would be, and it would be equal to 0, right? Current, right? So to remove this, like parse my current element. Now what I'll be doing it, what I'll be doing here in this loop over it, what I'll be doing, just find the biggest element. If let's say if current is greater than, let's say if current is greater than largest. Okay, so what I'll be doing, I will be putting my, what I'll be doing is like I will be putting my largest element, my second largest, let's say second largest would become largest, right? And my largest would become, uh, let's see, my largest would be current. if if I have, let's say, if my current if my current is less than smallest, right? If my current is less than second largest, let's say greater than current second largest, what I'll be doing is, you know, uh, let's say make it make my current second largest as current, right? With this I have got, and with this I will end my first loop. That is, with this I have found my largest and second largest here. I have found my largest here. Similarly, for finding the smallest, for smallest, right? What are we doing again? Current uh, would be like nums dot length and greater than equal to 0. If greater than, it should be greater than equal to 0. Perfect. Now what I'll be doing, again loop over. Now I will let this, if my current is um, if my current if my current is less than smallest. Similarly, if my current is less than smallest, what do I need to do? What I need to do, I will just need to like put my current as my my current is less than smallest. My second smallest would be smallest number, and my smallest would now become current element. This I have found two elements: smallest, second smallest, greatest, and second greatest. Now let's say if it ever becomes, now if my, let's say, current is less than second smallest, if my current is less than second smallest but greater than a but greater than smallest, right? What do I need to check? I need to put as second smallest would be equal to current, right? Perfect. This I found my, again in the loop. Okay. This I found my smallest, second smallest, and greatest, the second greatest. Now it should be easy. Now then my answer return. Now what I'll be returning? Return. Just return the smallest, return it. Greatest, let's say largest, largest into second largest minus smallest into second smallest. Perfect. Right. That's what I'll be returning. Space would be open. Time would also be open. Space would be off one, and time would be open. Now let's just like code it. Just code this shit. Let's just try to code it. For int, let's say for int I, let's say current equals to 0. Current is less than nums dot length current plus plus. That's it. Right. If my oh wait, I think I deleted something there. Yeah, perfect. And if my largest is current is greater than largest, current is greater than largest, what do I need to do? My second largest would be largest. My largest would be current. Hmm. If my else, I think I should be using else. Else, if my current is greater than smallest, let's say largest. Second largest current is greater than second largest. What I need to do? Current is greater than second largest. It's automatically. What do I need to do? My second largest largest would be current. Now what about next is if my current, I think I can use a switch case here. If my current is greater than, my current is less than smallest, what do I need to do? I need to make my second smallest as smallest, and my smallest will be current. Else it would be current would be my second smallest would be current, right? Therefore, possible if my element is none of these, like else if my second smallest is greater than current. Let's say if my current is less than second smallest, then only put my second smallest as current, right? I need to just return, simply return this v control v. Perfect. Nothing to change here. Largest minus smallest into second smallest. How should I initialize my int? My largest would be my largest would be integer dot n value. Oh shit, can I contain negative values? No, not numbers of files. Okay, which let's say largest would be 0. You can just do that. My smallest would be second largest also should be see my largest my smallest will be integer dot max value and again see control V second smallest CCONT max value minus 1. You can just make that perfect. It should be enough. Let's just sudo let's var in it. We have 5. Okay, now current if my current is okay okay. My hint current say current over numbers. Perfect. Greater than largest, that's true. My second largest would be again it would be 0 no matter. Then if my current is less than smallest, that's true. Doesn't matter. Now I have 6. Now it's largest, perfect, it is largest. Now what if I had here a 1? My largest would be same if my greater than my second largest would be 1. Perfect. It should run now. And now it's 6. My largest would be my second largest would be 5. Smallest is initially my smallest had 5. Current is 6. My smallest was 5. No, that's not my smallest, my 5. Else my second smallest would be 6. Check where it's falling behind while parsing. Okay. Alright. In spelling mistakes, man, they take a lot of time. Perfect. How about if there's a single value? Okay. Oh no, there are minimum 4 values given. Okay. Perfect. What if there were a single value? No, that cannot be done. Perfect. 4 values. Let's just say perfect. 2 milliseconds. Damn. Description. Equals my summations. But is also good. Sorting, comma, you have a method of, let's say, what's that method called as? Initialization. Not initial. Queue. You can take queue, priority queue. You can make use of priority queue. Perfect. Sorting and priority queue. Well, No, clarity queue, perfect. Now what do I need to check? 35 minutes. Back. Return the maximum search product difference. Perfect. Perfect. Bare hard. Perfect, perfect, perfect. Now what I need to like, yeah, I need to add space and time complexity here. Okay, my space is come on. Space of one, time is O of n. Current is n is the north length of the array. Now space and time, perfect. Oh yeah. How did you get 1 millisecond as answers, man? I think it's num suffice basically. Now I can let me just check some solutions. Mean, max, max. Okay. If num suf is greater than EA, or you can make mat dot max of nums of A. Num is greater than A, or if num is greater than B. And dot max of A comma B num. Oh yes. Perfect. Yes, it would be like you can just like short it. Make if my current is greater than or A, my largest, if it's greater than largest, or if its current is greater than second largest. Even if that's true, then what do I need to do? Largest math dot max of A comma B, and second largest would be math dot min of not A comma B, largest and second largest. Oh wait, no, A is the largest, current min of largest comma, right? Not mean, it should be like if it's greater than largest, then my largest would be current, right? Otherwise, if it's greater than second largest, then my largest would still be largest, and my second largest would be. Oh wait, it should be something like second largest, comma. If my current is greater than second largest, right? But it's smaller than largest, it would be minimum of second largest. But what if my current is greater than largest? Then my largest would be current, and my okay, perfect. Similarly, would be the case for B if my current is less than smallest. Let's see if my current is less than smallest, and if my current is also less than second smallest. Second smallest. Right? My smallest would be mean of smallest and current, comma current, and my again, if this condition is true, what will happen? My smallest, my current, my smallest will be new, and but this current will level, and what will happen to that smallest? Hmm. And that mean of smallest and current. So current would and smallest would be holding the same values. But how about second smallest? I need to first place here second smallest. Let's say here initially mat dot max of largest and current. If let's just check for this condition, current greater than largest, mat dot max of largest and current largest would be my second largest would be no. I think I need to first control C. It would be and then make because if this condition is true, my largest would be current. Then my second I need to first place my second largest. Okay, my second largest would still be second largest. But what about this? Okay. How should I like incorporate it? Current is greater than largest. So I first need to place my largest into the second largest. Then if here would be max dot max, it would be like max dot max of largest and second largest. But what if this condition is true? Current greater than second largest. My second largest would again be become largest. I don't want that, right? Oh, okay. I can make here that second largest, comma current, right? Not current. Hmm. I think this is something a bit dicey. Let me check what he had done. No, see, let's say this continues. Current is greater than largest. And second largest would be man dot max of current and largest. True. Largest would be man dot largest and current. Second largest would have no. I think if I place here largest, it's here largest. What will happen? My second largest would be have largest value, and my largest would be related to current. Perfect. But what if this is true? Current is greater than second largest, but it's less than largest. So what will happen? Second largest again would be have man dot max of second largest and largest. Largest would remain the same, but second largest would be updated to largest. He had done submissions accepted runtime 0 second. Man A and B, but and the other number would be current number. Okay, let's see. Let's see. My largest would be this. That's true for all the cases. Like my yeah, my second largest would just become current. In any case, that's true, right? Similarly, here my smallest would be man dot min of smallest and current. Yeah, and my second largest would be Smallest, not smallest. It would be current. And let's say yeah, second largest would be current. Why? Because if it's I think it's a bit dicey, you know. Num is current value, right? A equals to max dot max of A and B would be that number. Why? But why? Let's see. If A is the max variable, right? A is like, let's say if my num is greater than A, then my A would be okay. It's max of A and B. Okay. Max of largest and second largest. But isn't second largest always greater than smaller than? Then that condition would always be true. Okay. I'm here making a differentiation between largest and second largest, right? But if it goes into any of the values, I don't care, right? Let's say you don't differentiate between largest and second largest. Here it's like I don't matter if it's largest or second largest. Let's say let's just make this value as A and B. A and B. Right? These will have maximum values, like big values. It doesn't matter if it goes into largest and second largest because I just need their product and product is like commutative. So what if I say my A would be mat dot max of A and B, right? Here B would be something like here, doesn't matter because A and B are same, doesn't matter, and my B would be just current, right? Why? Hmm. Yeah, they both might change position. Largest and second largest will change position. Similarly here, C would be math dot min. No wait, control Z. It would be like C and D. D and D. Right. Here it's C and here it's D. Similarly, I will have control V. I will have here as A, B, here is C, A into B. Run. Submitted. Okay, I think I learned something new. 1913. Perfect. 193. Wow, what should I state? 1224. No, 1. Oh, 123. Perfect. 3. 3. Maximum broad between two pairs. Right, that's main issue. Okay, so here find one is first method is like sorting, then you are using priority queue. Then second is find largest, second largest, the smallest, second smallest. Now in this traditional method, second method is since A into B largest into second largest. Second largest is equal to second largest to largest. Since both are same, you don't need to find distinguish between them. So even if my let's say if my A is greater than num, or if my B is greater than num, then my A would be math.max of A and B. My B would be num. A and B would be switching positions as largest and second largest. Let me just try example. So like let's say 5 6 2 4 7 5 6 2 7 4. Okay, initially A equals to max, it's a mean, and B equals to mean. Now A would be 5, no, A would be 5 and B would still be mean. Right, second case, A would be man dot max of A comma B. A would be 5 and B would be mean 6. Third case, again A would be 6 and B would be no, not case. Num is less than A and num is less than B. Fourth case, less than num is here, 2 is less than 5 and 2 is also less than 6. Third case, A would be 6 and B would be 7. Fifth case, 4 is less than 6 and 4 is less than 7. No, I think it's more. say if my num less than equal, but num is greater than b. So my a would be b. Oh, initial condition does matter. If my a is greater than the initial, b would be initially if my a is greater than b, but num greater than it, I think it would be num. So it's largest, second largest, now it's largest. Okay, so it would swap positions. Perfect. Now let's move ahead. And average view duration is 46. Who the fuck is watching, man? Oh, it's 46.6. It's like same almost. Then let's just move ahead. Balloons. Array easy. Tags array. Pick one. I think I reached 46 minutes on a single motion. Man, I think I should just. Oh, shuffle string. Here are of numbers of I. Oh, I think it's here. Like when a string as an integer and has same length. Each of the string as equals to code index is 4. It now this C would be like C. You can just convert it into an array of characters. Let's take an array of characters, right, and convert it into using new string. I think I have made it. Yeah, new string and array of character. You can make it like 4. My array of character equals to character of, let's say its index is 4 of indices of I should be equal to s dot character at the position of I. Perfect. I think move ahead. That's all. Let's just practice next question. Easy. Tags array. Pick one. Find all numbers. Oh, I think I solved it. Oh, I think I solved it. Yeah. No. Find disappeared numbers. Well, but not that. I think I have just like submissions earlier. Yeah. It's July 2022. Oh well. Last year. Last year. Okay. Given an array, let's start the time. Given an array nums of n integers where nums of I is in the range of 1 and n, return an array of all integers in the range that do not appear in nums. Okay, 5, 6. Oh shit. I think it's like 5 and 6 don't appear. Given an number that is in the range of 1 to n, return an array of all numbers. Okay, 4, 3, 2, 1, 5, 2, 3, 1. Doesn't matter, 5, 6. Okay. 1 to n, the sum should be like. Okay, okay. Okay. So, what I think initially what we can do is like, what is the length array? 10 is to. Okay. If I know, I think if I make like 4, yes, I have found 4, I have found 3, I have found 2, okay, 7, 8, found 2, 2, found 2, but it's not there. If in a way I could like there's a way if I could like previously know which numbers I have found and which numbers I do not have found. It's like if I separate numbers. Oh wait a minute. 4 found. Okay, 3 found. 2 found. 7 found. 8 found. What if I make 4? One is the, like first you can make a brute force method. Like it would be uh, put this in a hash set. All these numbers in a hash set. Right. Then if it is present, then traverse over that hash set. Right. But how do I know which 5 is missing? Okay, you can use sort. Sort these elements. Sort. If it is found, sort the elements. Right. If the element is not in its, if the given element is not, let's say 5 should be in n minus 1th position, right? N minus 1th index. If 5 is not present at that 4th index, then for return false. If again 6 would not present, add it. So it would take off and log. Sorting first is like sorting sorting if element not present in nums of I, if my current element is not equal to current element is not equal to, let's say, nums of I, right? Perfect. No, I think it should better. Wait a minute. 1, I is passing 1. Okay, 1 is equal to current element minus 1 minus 1 minus 1. Okay, minus 1 is not equal to nums of I. Not in my current element. Oh, wait a minute. My current element would be nums of I. Okay, if my current, let's say current element is nums of I is not equal to I minus 1 is not equal to I, then add it. Add to list. Perfect. Hello. Then move ahead. Oh wait, and this is what like of n method, of n log n. Time would be, space would be O of k, where k is number of disappeared elements because I would be adding it to list. Time is O of n log n. So now what? How should I increase it? If I can like make a sum of, I do know the sum of n elements, right? N into n plus 1 by 2. Is it like something related to that? Something maths involved in it? Uh, no, I don't think so. Okay, if I don't sort, let's say 4. 4 has appeared. Perfect. But its position is, okay. What if I like Sort that. Okay, yes. Counting sort. Count sort. Yes. Count sort is better. If I place it on the n minus 1th index, let's say 4th. This solution is demand for counting sort. Okay. 4th. Right? I'm here at 4. Its index is 3. 0, 1, 2, 3. Swap it. 7 and 4. Okay. Now 7th element's index would be, let's this like sixth 0, 1, 2, 3, 4, 5, 6, 3. 3th element will be 2, 0, 1, 2. 2 would be 1, 0, 1. But I had 3 here. But I do have a 3. So what should I do? Push it behind or forward? Now that's matter. Now that's like, okay, let's move ahead. Instead of like standing in that position, I will be moving ahead. Okay, 4th. But I need to take my pen and pencil. What's the finding all? All disappeared. Hearing numbers. Right? Let's say if I like 4, its position is n minus 1 indexes, so it should be on 3 first, second, 0, 1, 2, 3. So let's just make use of paint. Right? Oh no, instead of paint, I think I should be like making use of here. Control C, Control V. Okay, its index is 3, so it should be like Control C, Control V. So 3, 7 and 4. This is the first step. Move ahead. I am at I. So my my need to like 2, 2, 0, 1, 2. 2 would be here and 2 would be here and 3 would be here. Perfect. 1, 2, 3, 4, 5, 6, 7. Right. Now I'm at 4. 3, 4. Perfect. 8, 0, 1, 2, 3, 4, 5, 6, 7. 0, it should be present at 7th index. My 1 would be here and my 8 would be here. Okay. 2, but position is occupied. Don't know. 3, position is again occupied. Don't know. Let it remain here. Okay. 1. Okay, no, wait. 3 and 8. No, I think I should be 0. Okay. Now I need to like 7. C, Control V. 7 again on 6th position. 0, 1, 2, 3, 4, 5, 6. 3, 7. Again 3. It should be 2. 3, 2. 2 should be on first position. 2, 2, no, 2, 1. Not 1, no, 3. 2 should be in first. It should be 2 should be limit. 7 I have, wait a minute. 7 I have like 6 position, which would be 3. 3 should be here and 7. Now I need to replace 3 in 2 and swap 2 and 3. 3 would be here and 2 would be here. Perfect. Now again replace it. V 1. 2 would be here, 3 would be here, but 3 has been occupied. So what should I do now? Let just remain. Let like move ahead. 2 same 3 position. 4 8 1 would be here and 8 would be here. Now 1 swap position with 3 and 4. 1 would be here and 3 would be here. Again move ahead. 3 is position is present. Okay, move ahead. 2 position move ahead. 7 and 8 are again same. So stop here. Now what are the positions which have 3 1 2 3 4 3? Fifth position 5 and 6 are the elements which are not present. Now if I keep a pointer, let's say I have introducing a pointer now, let's say pointer variable. No, I think I should not add. And then I will be traversing if that element is not present. Move ahead. Now this would be taking of n. What time will counting sort take in this case? It should take an of n time. Okay, well, now how I will be proceeding, right? Let's say sorting. Now counting sort. Just move ahead. Let's say my nums of I would be equal to swap. Okay, just swap nums of I and swap nums of I and with fourth would be going to its fourth index. Fourth would be now swapping nums of I initially and fourth. Third index. Nums of I minus 1. Right? 4. Let's say nums of I is current. Initially define it as nums of I to current element. Right? Now I will be swapping current element as well as nums of current element minus 1. Minus 1. Okay. This is what I will be doing pseudocode. Right? Then move ahead again. Move ahead. Swap. But if don't swap if my current element is not equal to swap only current swap only in these cases, otherwise move ahead. Right? And then traverse parse array and add missing element. Perfect. It should be pseudocode. Easy. Counting sort was the main issue. Okay. And now I'll be so. Okay. Thanks for watching, motherfuckers.